Hello everyone, welcome back to Python and Pandas tutorial series. In this video, we will discuss about recursive functions in Python. So what is recursion? Recursion means when a function calls itself. And in this video, we will cover what exactly recursion is and why we use that. And then we will see how to define a recursive function and what is base case and what is a recursive case, and we will see some examples of using recursive function when we want to find factorial of a number, Fibonacci series, and sum of digits. We will also see when to use recursion and when to use loops. So to start with, recursion is a powerful technique that allows a function to call itself to solve smaller parts of a given problem. So we will be having a function call inside the body of the function itself, but with some modified value for the argument. We will go step by step, starting with the basics and moving to the real world examples. And before we see some examples, it is important to know two factors here. One is base case and other is recursive case, because every recursive function has these two key parts. And what is a base case? A base case is termed as the condition where exactly the recursion should stop. Means it is a condition when it is met, we are not going to call the function again. And recursive case is the part where the function calls itself with a modified argument value. So recursive case means it is the part where we are deciding to call the function again, but by providing modified argument. Let us see this in examples. Open your Visual Studio Code and create a new file called recursondemo.py. In this we will have some examples. Before going into the actual examples we were talking, let us see using a simple recursion just to implement some countdown. Maybe I have a requirement to write a function that counts down from a given number to 1. Let us see how to write that. So let us define a function using the keyword def and name that as countdown, and it has a parameter n so that user provides the value from which the countdown should start from. And in the body, we will see two concepts as we were discussing. One is base case and other is recursive case. So what we discussed earlier, base case means it is a case where we have to stop the recursion. So whenever we are doing some countdown, we know when the counter is here, n is the counter. So when n is equal to 0, or even when user gives some value less than or less than 0, then it should be the base case and we are not going to continue the recursion anymore. So the condition or the base case here is if n less than or equal to 0, right? In this case, we should stop the recursion and just need to print some statement like maybe done. Got it? And now let us see the recursive part of this. So simply the recursive part here is the else part for this. Means the n is given n is not less than or equal to 0. So we will write else, and this is the recursive case where we will be calling countdown recursively but with n minus 1, and this is the else part. And before just calling that, we can simply print the value of n so that it acts as a counter. So for example, if user calls countdown with 3, it comes here. Because the base case is not true, it goes to the recursive case and it prints 3, and countdown will be called again with n minus 1, which is 2. And again, the body of countdown will be executed with 2. So the base case is false again with 2. 2 is not less than or equal to 0. Hence we will come to else again, and 2 will be printed and another recursive call will be made with 1 because 2 minus 1 is 1. And even for the value of 1, the base case is not true, so it goes to the recursive case and prints the 1, and it calls the countdown with 1 minus 1, which is 0. And when n value is 0, it satisfied the base case itself because it is equal to 0. 0 is equal to 0, and hence it prints done and it comes out of the function. See, this is how countdown is calling countdown itself from inside its body. So if user calls countdown with 3, you can see, I'll clear the console and Python recursion demo.py. You can see 3, 2, 1 and done. Got it? This is how. So if user calls this countdown with 5, they will see 5, 4, 3, 2, 1 and done. So this is how recursion works, and this is about base case and recursive case. And now let us see one of the classical example of recursion, which is finding factorial of a given number using recursion. We can find the factorial using iteration as well, but we will see how to find it using the concept of recursion. So let us create another file and factorial using recursion.py. In this we will see that example, and if you don't know, factorial of a given number means product of all numbers from 1 to that number. So 3 factorial is, which is represented by 3 and an exclamation, it is 3 into 2 into 1. Got it? So 4 factorial means 4 into 3 into 2 into 1. Right. If you observe these two, 4 factorial means 4 into 3, 2, 1 are multiplied again, which is 3 factorial itself. So if you see the 2 factorial, then it is just 2 into 1, this one, and 3 factorial is 3 into 2 into 1. So we can say the formula for the factorial is whenever we are asked to find the factorial of n, it is n into n minus 1 factorial, right? So n minus 1 factorial, because 4 factorial is nothing but 4 into 4 minus 1, which is 3 factorial. This is the 3 factorial. And 3 factorial is 3 into 2 factorial, which is 3 minus 1 factorial. So finding n factorial is nothing but finding n into n minus 1 factorial. So we will see an example for this. We will define a function called factorial of n, and in this determine the base case. So what is the base case? If we see here, I will expand this with 1 factorial as well, which is just 1, right? And what if user provides 0? The factorial of 0 is 1 as well. Okay, so we just need to take the factorial of 0 as 1. So this is the base case where we should stop, right? So whenever we reached 1 or 0, I mean we don't need to reach till 0 from program. I mean we don't need to reach till 0 programmatically, but there is a chance user may give 0, so we have to handle that as well. So consider that as a base case. So if n is equal to 0, or it might be 1 as well, right? In these two cases we should print, or we should get 1 only. So we will simply return 1, so that we will be doing the calculation. And what if this is not 1? So we will write that in else part we simply need to return the value of n multiplied by factorial of n minus 1 again, right? So this is what we have seen in the formula as well. So this is simple. Factorial of n is n into factorial of n minus 1 again. So if we are asked to find the factorial of 3, what it does is it comes inside, because the base case is not true, it goes to the recursive case, it will return 3 into factorial of 3 minus 1, which is 2. So we have 3 into factorial of 2, and whenever we are finding factorial of 2, it goes inside and still the base case is not true, so it comes here. We have 3 into, and the factorial of 2 is 2 into factorial of 2 minus 1, which is 1. So 3 into 2 into factorial of 1 we have. So when it is called again with 1, n is 1, it's satisfied and it returns 1, and hence we have 3 into 2 into 1, and the factorial function is going to return 3 into 2 into 1 at the end. Got it? So try calling this factorial of 5. Maybe it is 120, so we will see if it works. So Python and factorial using recursion.py. Sorry, I called this, but I did not print it. Print factorial of 5 and run this again, and we will see the factorial of 5. And if you call this factorial of 2, then we will see 2 into 1, and factorial of 3 is 3 into 2 into 1, which is 6. Let us see with 3. So 6. So this is how we find factorial of a given number using recursion. And let us see another example to find the Fibonacci series. So create another file, Fibonacci series using recursion.py. In this, we will find a Fibonacci series of, till the given number. So what is Fibonacci series? So Fibonacci of any given number. So I'll put this in comment. So Fibonacci series any given number is nothing but Fibonacci of that number minus 1 is added to Fibonacci of n minus 2 also. Okay, so we will be finding Fibonacci series of two numbers before that, and we will be adding those till it reaches 1 or 0. Right, so we will write this. So we will define a function Fibonacci of n, and we have the base case as if n is less than or equal to 0. Probably if user provides that value, then we simply return 0. Okay, so no, user did not provide any value that is not negative. I mean, user have not provided any negative value, or is not provided 0 also. Then we have another condition, L if n is 1. So user has passed 1 or our recursion reached till 1. Then we simply return 1. Okay. Else, which is the recursive case, in this we simply return our formula, which we know Fibonacci of n minus 1, Fibonacci of n minus 1, and add it to Fibonacci n minus 2. Got it? So this is the way how we use a recursive function to find the Fibonacci series. But here we have a problem, because we are doing multiple calculations without memorizing those, because we are doing Fibonacci of n minus 2, and again for that we will be doing Fibonacci of n minus 1, which might be the same value for other number. So we are doing unnecessary calculations, and that can be avoided if we use dynamic programming, but we will discuss that in later videos. For now, we stick to the recursion concept to find Fibonacci series as well. And now just call this with maybe 6, and you can see the numbers are added up. So I save this and clear the console. Python Fibonacci series demo. Sorry, I have not printed this again. Print. So which is 8. Got it? Which is nothing but the sixth Fibonacci number. Let us see another example of using recursion. So we will try to find the sum of the digits of a given number. So I will name my file as recursion demo2.py maybe. Okay. So in this we will write a function so that we will be finding sum of the digits. For example, if we provide 1, 2, 3 as an argument, it should return 1 plus 2 plus 3. So this should be the output, which is 6. Got it? So let us define a function, maybe sum of digits. And in this, we will take a parameter n, and the base case is whenever it reaches till 0, then we just return 0. That's all, because we are summing up. So if it is 0, simply return 0. If it is not 0, which is the recursive case, simply return the last digit. How we will find the last digit of any given number? So by doing the remainder operation. So 123 is the required number. So if we do 123 percentile 10, what it will result in is 3, right? So it will divide 123 with 10, and the remainder is 3, because 120 is the value 12 times, so 3 is the remainder and it will be returned. So we are able to get 3 out of that. So we simply add the value of n percentile 10 to sum of digits of the remaining number, means 123 percentile 10 we already identified, so we were able to capture 3, and the remaining part of the number is 12. So how to get 12 out of 123 means simply do n by 10, so that it will do the this one, not by 10, because in Python we have float division is 10, so we'll get 1 2 out of that. Got it. So this is the recursive call, and let us see by calling this print sum of digits of 123 itself. And if we save this Python recursion demo.py, we can see 6 is the output. And if we try to add 1 2 3 4 as well, then the output should be 1 plus 2 plus 3 plus 4, which is 10. Let us see calling the same thing again with 1 2 3 4, and if you run this again, you can see 10 in the output. So this is how we use recursion. So just to recap, what and when to use recursion is, recursion means calling a function from that function itself. And when we use that means whenever we have some problems that can be broken into smaller sub problems. And when solving problems like some tree data structures, graphs, like that also we will go for recursions, we will see in future. And whenever we feel like iteration is not a best fit, then we can go for recursion. But if you are concerned about performance, then recursion is actually a bit slow and it occupies some extra memory. So you have to avoid recursion in those cases. So that's all for this video. In this we have discussed like what is recursion, and what some different examples of recursion, and we have seen what is a base case and recursive case, etc. Let us see some other concept in the next video. Thank you for watching, and please don't forget to like and subscribe.